matter and its properties. Section 3, elements. Section 3, elements. Objectives of this lesson. By the end of this lesson, you should know or understand the purpose and importance of the periodic table, know the origin of the symbols of the elements, understand how the periodic table is organized, define periods and groups. So define what? Periods and groups of the periodic table. Outline of the lesson. How would the periodic table constructed or arranged the number? How? Origins of the names of elements, groups and periods. What meant by elements? Element is a pure substance that cannot be broken down into simpler stable substance. Like what? Like carbon, for example. Carbon, made only of one type of atom, so we cannot broke this element into simpler or this substance into simpler stable substance, so it's an element. Another example, like oxygen, O2, also made of only one type of atom, which is oxygen, so we cannot break it into simpler stable substance, so it's an element. We have 120 elements in the universe. So we have how many elements? 120 in the universe. 94 of them are found in nature, while 26 are synthetic. So we have 94 elements of 94 of elements are found in nature, while 26 are synthetic. All elements are organized in a table called periodic table. So these elements, 120 elements, are organized in a table called what? Called periodic table. According to what? According to their atomic number and chemical properties. So these elements organized according to their atomic number and chemical properties in the periodic table, like this. This is a periodic table. Elements arranged or organized in a periodic table according to the number, atomic number and chemical properties. The periodic table organizes elements by their chemical properties and also atomic number. Each square in the periodic table chooses the symbol for an element and its atomic number. Like hydrogen, look, hydrogen, square of hydrogen show the symbol of hydrogen and also the atomic number. For example, the first square at the upper left represents element 1. This is atomic number hydrogen, which has symbol what? H. You will see many familiar elements like iron, sodium, neon, silver, copper, aluminium, sulfur and lead. You can often relate an element symbol to its English name. So this symbol, according to this symbol, like H, according to its English name. Some symbols come from the element's older name, but not of all according to its English name, but some of them according to older name, which was often in Latin, so according to Latin name, and also other according to German name. For example, the symbol W, it's a symbol for tungsten substance, so the symbol of tungsten substance is a W. Comes from what? It's a German name, Wolfram. So tungsten in German called Wolfram. Called what? Called Wolfram. So the symbol of tungsten W according to its German name. Copper. Copper, symbol of copper, Cu, according to what? Its older name, copper. Gold, Au, according to its older name, Urium. Iron, Fe, according to its older name, Ferrum. Silver, Ag, according to its older name. So not all elements or elements simple according to its English name. Some of them according to older name, and which is Latin, and other according to its German name. Watch this video.
The truly periodic table. The periodic table is this chart with a strange shape, with letters and numbers, neither a square nor a rectangle, with such a characteristic shape. Unmistakable. Some people know what each of these letters represent. C is the chemical symbol for carbon. O is the chemical symbol for oxygen. The chemical symbol for iron is Fe. Zn is zinc. There are even those who know the chemical symbol for sodium is Na, because it comes from the Latin natrium. Or that the chemical symbol for gold is Au, because in Latin it was called aurus. And also some know the meaning of the numbers that appear next to the letters, like for example the atomic number, which is the number of positive and negative charges of the atom. But what exactly is the periodic table? The periodic table is a chart that represents all 118 chemical elements that constitute the known universe. Everything around us is made up of at least one of these elements. 94 of these elements can be found in nature, and the rest were obtained in laboratories. 118 elements may seem too little for an entire universe, but it's not. Let's see. In stars like the Sun, 94% of all the atoms are hydrogen. The human body itself is very scarce on chemical elements. For every 100 kilos of weight, 65 kilos are oxygen atoms, 18 kilos are carbon atoms, and 10 kilos are hydrogen atoms, which leaves little room for all the other essential elements. Nitrogen, calcium, phosphorus, potassium, sulfur, chlorine, sodium, magnesium, iron, cobalt, copper, zinc, iodine, selenium, fluorine. The wonder of the chemical elements is that they combine with each other, and there's an almost infinite number of possible combinations that produce all the different chemical compounds needed to keep us alive and build everything around us. The water we drink, obtained by combining an oxygen atom and 2 hydrogen atoms. The glass we drink it from. The sugar in our coffee. The coffee. The cup and the metal of the little spoon we stir it with. The plastic our computer is made of. The rubber on the tires of our car and the gasoline that makes it run. Proteins. DNA. Everything around us and inside us are atoms that combined. An atom is the smallest recognized division of a chemical element and consists of a central core, with protons, positive charge, and neutrons, no charge.
That's it. This is a periodic table, look here. Periodic organize the elements according to its atomic number and chemical properties. The vertical columns of the periodic table are called what? Called groups or families. So the vertical called groups or families. So group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and also here 18. So note that they are numbered from 1 to 18, from left to the right. Each group contains elements with similar chemical properties. So each group like for example group 1 here contain elements with similar what? Chemical properties. So the chemical properties of hydrogen is the same as lithium, as sodium, potassium. So elements in the group 1 has a similar, or in the groups have the similar chemical properties. For example, the elements in group 2 here, beryllium, magnesium, calcium, strontium, barium, radium, all of these elements are reactive metals, so and also have similar chemical properties. These metals are reactive metals. Reactive can react easily with similar abilities to bond to other kinds of atoms. The two major categories of the elements are metals and non-metals. So the elements divided into three categories. The first two major categories are metals and non-metals. The third one, metalloids, have properties intermediate between those of metals and non-metals. So have intermediate properties between metals and non-metals. So elements divided into three categories: metal, non-metal, metalloids. The two major categories, metal and non-metal, but metalloids have properties intermediate between metal and non-metal. But the horizontal row of elements in the periodic table are called periods. Look here, the horizontal, like this, horizontal, called periods. Physical and chemical properties change somewhat regularly across a period. So, chemical properties and physical properties change according to period. For example, potassium, the chemical properties of potassium different from the chemical properties of calcium, and so on. For example, in period 2, the elements lithium and beryllium in group 1 and 2 are somewhat similar in properties. However, the properties are very different from the properties of fluorine. In period 2 elements, the elements lithium and beryllium, in group 1 and 2, lithium in group 1, beryllium in group 2, are somewhat similar in properties. However, their properties are very different from the properties of fluorine. But fluorine here, its properties is different from lithium and beryllium. So physical and chemical properties change somewhat regularly across a period. Elements that are close to each other in the same period tend to be more similar than the elements that are farther apart. So lithium and beryllium have similar in chemical and physical properties, but different, similar, not the same, not exact same, but different from fluorine. Sorry, fluorine. This is fluorine. Different from fluorine. The two sets of elements placed below the periodic table make up what are called lanthanide series and actinide. So we have two groups or two rows of elements called lanthanide and actinide. Here, lanthanide and actinide. Here, lanthanide and actinide. These metallic elements fit in the table just after elements 57 and 89. They are placed below the table to keep the table from being too wide. So they're only placed below the table to keep the table from being too wide. Lanthanide and actinide present in or fit in the table just after element 57 and 89. Between 57 and 89. Here, present here. Present here, between 57 and 89. So, the chemical and physical properties of elements in the periodic table are in the period physical and chemical properties in the same period are different or regularly change across the period. So physical and chemical properties change somewhat regularly across the period. Elements that are close to each other are similar, but or are more similar than the elements that are farther apart. For example, lithium and beryllium in group 1 and 2 are near to each other. So lithium has similar properties like beryllium, but different from fluorine, which is far apart from the lithium. Watch this one video.
As you move from the light elements to the heavy elements, you keep periodically coming across the same properties, which is why it's called the periodic table. The recurring properties are organized so that you can easily see similarities between elements. The periodic table is arranged in periods and groups, going from the light elements at the top to the heavy elements at the bottom. The rows going across from left to right are periods. Elements in the same period all share something in common. They have the same number of energy shells. Each new period row represents a new shell. Elements in the first period have one shell, and as we go down, the shells increase. Hydrogen is in the first period. It has one shell. Potassium is in the fourth period and has 4 energy shells, as do all the other elements in this period. The columns going down from top to bottom are the groups. Elements in the same group also have something in common. Elements in the same group have the same number of electrons in their outermost shell. The electrons in the outer shell are called valence electrons. This just means that these are the electrons available for reactions and bond formation. The number of electrons in the outer shell governs elements' reactivity, which is why elements in the same group have similar properties. The group number can tell you how many electrons are in this shell. For example, let's look at group 7. Fluorine, chlorine, iodine, bromine, and astatine. They all have 7 electrons in their outermost shell and all exhibit similar chemical characteristics. The properties show a gradual change going down the group as we go from period to period. So, if we look at group 7 again, we can see that they are each in a different period in the periodic table, telling us that each element in this group has its outer electrons on a different shell. So, chlorine is in group 7, period 3. Therefore, it has 3 energy levels with 7 electrons in its outermost shell.
That's it. Thanks for watching.